Greetings and welcome. So in continuing our look at perpendicular vectors, um, earlier we just looked at the dot product of vectors, which gave us a number which served as kind of a litmus test to determine whether or not two vectors were in fact perpendicular. And that was called the dot product or the inner product. In this case, our next formula is going to be the cross product of our two vectors. And the cross product between two vectors, the value of it is this, is that if I have any two vectors, those vectors are by default going to be forming a unique plane, unless for some reason they were parallel or coincident. Now, when I get the cross product, instead of this equaling a number, it's actually going to give me a new vector. And this new vector is specifically going to be the vector that is perpendicular to both of vectors A and B, as well as the entire plane that they are on. So it would be kind of perpendicular to both of those and this entire plane. Okay, so this is valuable in certain physics problems when calculating forces like torque or different things like that. And that's going to be the value of this. So this is going to give us an actual new vector, not just some number. All right, and so if I have two vectors, let's say vector A is A1, A2, A3, separated with commas, and vector B is B1, B2, and B3, then the cross product, and this can be defined multiple ways, is going to be the determinant of this 3 by 3 matrix in which I have I, J, and K, which are our unit vectors as being kind of the first row of this matrix. And then each corresponding row will be the coordinates of the two vectors that I had. So it would be A1, A2, A3, and B1, B2, B3. And then when I multiply this, this is going to give me sum of vectors I plus J plus K, where I will have kind of three coefficients here, which will end up being kind of the values resulting from doing some of these diagonals and all of that. And I could then also take those coefficients and write them out as their own ordered triple if you wanted to as well. But that's the idea, is it's going to equal the determinant of this matrix, and it will give us a vector that is perpendicular to the plane that we are on. One of the things I want to point out is I believe if you change the order that you do it in, it will give you a vector that is in the opposite direction. So I just want to point out that your perpendicular vector might be kind of quote-unquote underneath the plane or above the plane. So that's kind of the idea. So let's do an example of this, in which, actually I'm going to steal a problem right here. Let's see, so find the cross product, and then once I do that, we'll actually be able to use the inner product or dot product as a check to verify that our answer is in fact perpendicular to both of our starting ones. So then use the dot product to check perpendicularity. Okay, So let's say I've got my two vectors. Let's say vector A is, let's see, we'll do 5, 2, 3. And let's say vector B is negative 2, 5, 0. So in order to find the cross product, let's see, hopefully you guys have brushed up on your determinant skills. So it's going to be the determinant of this 3 by 3 matrix, I, J, K. Don't forget our little symbols there. And let's see, so it'll be 5, 2, 3, negative 2, 5, 0. And the way that I've taught determinant in the past is that you rewrite the first two columns, kind of duplicated here, off on the side, like so. So 5, 2, and negative 2, 5. And we're going to actually multiply our diagonals here, like this. So let's multiply our primary diagonals first. So I times 2 times 0 is going to be 0i, right? That will be minus 6j. I always forget my little harpoons on the top. And that will be plus 25 vector k. And just remember that I is the unit vector along the x-axis of length 1, j is the unit vector on the y-axis, k is the unit vector on the z-axis. All right, and now let's multiply our secondary diagonals. So this is negative 4k's. This would be plus 15i. And this diagonal multiplying by 0, always nice to have, is 0j. OJ. And I don't know if you guys remember what we do with these, but we subtract the secondary diagonals from the primary. So let's see. I'm not going to necessarily write that all out. So let's see. I've got 0i minus 15i is negative 15i, right? Negative 6j minus 0j will still be negative 6j. And 25k minus a negative 4k will be plus 29k. All right, so another way I could write that is as an ordered triple, negative 15, negative 6, 29. Let's see, and I'm anticipating I might need a calculator for this next portion. So I've done this, and so I've represented my new vector in two forms. And this is a vector that is perpendicular to my original 2 and the plane formed by the original 2 vectors. So if I wanted to do a check, which we will right now, I'm going to check whether this is perpendicular against vector. Okay, and welcome back. Just had a power failure. We have a snowstorm here. So continuing, now that I've got it back. So what I'm doing, we just determined, we found a vector perpendicular to the plane defined by the 2 that we'd started with, and now I'm just doing a check verifying that our answer is in fact perpendicular to each of our starting values. So let's see, so I'm doing the dot product this time between vectors A and C. So I'd have 5 times negative 15 plus 2 times negative 6 plus 3 times 29. So let's see, that's negative 50 plus 25, negative 75. Let's see, a little slash on my 7 there. Minus 12. And this looks like that would be plus, what's that, 87? Yeah. And yeah, negative 87 equals 0. So what this tells us is that A is perpendicular to C. All right, and then we'll do the same check with B and C. And let's see, so vector b, -2 times -15, plus 5, sorry, mixing it up with the other one, times -6, plus 0, always gotta love 0, times 29. And I get 30 minus 30 plus 0, which equals 0. So therefore, B is also perpendicular to C. So since it's perpendicular to each, it must be perpendicular to the plane defined by each of them. Now, as far as the direction that this is going, I just want to point out it could be kind of pointing below or above the plane, depending on the order that I might have done my cross product in. So just be aware of that. And yeah, so it's not too bad. So this was our concept on perpendicular vectors and the two types of formulas. One is a check to determine perpendicularity, and the other, this cross product, gives you a vector perpendicular to 2 that you started with. All right, thanks for watching.